Crafting a high-performance data ingestion pipeline with Redis, Elasticsearch, and Spring Boot. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Introduction. The goal and tools. Building an efficient data ingestion pipeline is crucial for real-time analytics and search capabilities in today's data-driven world. This podcast will guide you through building a robust Elasticsearch ingestion pipeline using Redis, AWS ElasticCache, and Spring Boot. The goal is to combine these powerful tools to create a seamless, high-performance pipeline that ingests and retrieves data efficiently. Combining Redis, AWS ElasticCache, and Spring Boot for efficient data ingestion. Redis is known for its speed and flexibility, making it an excellent choice for caching and quick data retrieval. By integrating Redis with AWS ElasticCache, you can quickly scale your caching solution. When paired with Spring Boot, this combination offers a powerful and efficient way to ingest data into Elasticsearch, leveraging Elasticsearch's Java Client API for seamless integration. The Elasticsearch Java Client API provides a simple yet powerful way to interact with Elasticsearch clusters. Using this API within your Spring Boot application allows you to efficiently perform operations such as indexing, searching, and managing your Elasticsearch documents, enabling a smooth data flow from Redis to Elasticsearch. Setting up the Spring Boot project. Creating the project and configuring Maven. To start, create a new Spring Boot project using your preferred IDE. Ensure that Maven is configured correctly, as it will manage your project dependencies and build process. Address any Java version compatibility issues that might arise, especially when working with specific versions of Elasticsearch or Redis clients. Addressing Java version compatibility issues. Java version compatibility can often be a hurdle when setting up a project. Ensure that the Java version used in your Spring Boot application is compatible with the libraries and tools you plan to use. This will help avoid runtime errors and ensure smooth integration between Redis, Elasticsearch, and Spring Boot. Managing Maven dependencies and plugins. Essential dependencies for Redis and Elasticsearch integration. Your pom.xml file should include Spring Boot, Redis, Elasticsearch, and other required library dependencies. Here are some key dependencies. Dependency. Group ID org.springframework.boot/group ID. Artifact id Spring Boot starter data redis/artifact id. /dependency. Dependency. Group ID org.springframework.boot/group ID. Artifact id Spring Boot starter data Elasticsearch/artifact id. /dependency. Dependency. Group id org.elasticsearch.client/group id. Artifact id Elasticsearch REST high-level client/artifact id. /dependency. Understanding Maven build phases and goals. Understanding Maven's build lifecycle is crucial for managing your project effectively. Familiarize yourself with the core phases, such as compile, test, package, and install, as well as custom goals that may be necessary for your build process. Core and custom Maven plugins. Maven plugins are essential for automating tasks such as building, testing, and deploying your application. Consider using plugins like the Spring Boot Maven plugin to package your Spring Boot application and the Maven Antron plugin for custom tasks. Modeling the data for Elasticsearch. Designing a model class to represent Elasticsearch documents. When ingesting data into Elasticsearch, it's vital to design a model class that accurately represents the documents stored in Elasticsearch. This class should map fields to the corresponding Elasticsearch fields and handle JSON serialization effectively. Mapping fields and handling JSON serialization. Use annotations like @document, @field, and @IDA to map the model class fields to Elasticsearch fields. This will ensure that data is serialized and indexed correctly in Elasticsearch. Configuring Redis and implementing data retrieval. Creating custom beans for Redis configuration. To integrate Redis with Spring Boot, create custom beans to configure the Redis connection settings. This includes specifying the Redis host, port, and any necessary authentication. Retrieving data from Redis hashes. Redis hashes are a convenient way to store and retrieve data. Implement methods to recover data from Redis hashes and prepare it for ingestion into Elasticsearch. Developing the ingestion microservice. Building Spring controllers to expose data retrieval endpoints. Create Spring controllers to expose endpoints that retrieve data from Redis and prepare it for ingestion into Elasticsearch. These controllers will act as the interface between your application and the Redis data store. Troubleshooting Redis connection errors in Spring Boot. Common issues such as Redis connection timeouts or authentication failures can be challenging. Use Spring Boot's error handling mechanisms to troubleshoot and resolve these issues effectively. Ingesting data into Elasticsearch. Utilizing Elasticsearch's bulk API for efficient ingestion. The Elasticsearch bulk API allows you to ingest large volumes of data efficiently. Implement a service in Spring Boot that leverages the bulk API to ingest data retrieved from Redis into Elasticsearch. Creating a controller to manage the ingestion process. Create a dedicated controller to manage the entire ingestion process, from data retrieval in Redis to data ingestion in Elasticsearch. This will centralize the ingestion logic and make the process easier to manage. Handling different content parsing methods. Elasticsearch supports various content parsing methods, such as JSON and XML. Ensure your ingestion service can handle different content types and parse them correctly before indexing. Querying and verifying Elasticsearch data. Using Elasticsearch Search API to query ingested data. After ingesting data, use the Elasticsearch Search API to query and verify that the data has been indexed correctly. This will also allow you to perform searches and validate the accuracy of the ingestion process. Integrating Elasticsearch with Spring Boot Beans. Spring Boot provides powerful integration with Elasticsearch through Spring Data. Integrate Elasticsearch into your Spring Boot Beans to simplify querying and managing your Elasticsearch documents. Building the microservice for bulk data retrieval from Redis. Leveraging Redis capabilities for efficient data retrieval. Redis's in-memory data structure offers exceptional speed for bulk data retrieval. Utilize Redis commands like stall or lrange to retrieve large datasets efficiently. Implementing the microservice for ElasticCache interaction. To interact with AWS ElasticCache, configure your Spring Boot application to connect to your ElasticCache instance. This microservice will handle data retrieval and prepare it for ingestion into Elasticsearch. Conclusion: achieving efficient Elasticsearch ingestion with Redis. By combining Redis, AWS ElasticCache, and Spring Boot, you can build an efficient data ingestion pipeline that seamlessly integrates with Elasticsearch. This pipeline enhances data retrieval and indexing performance and provides a scalable solution for real-time analytics and search capabilities. Thank you for listening to our podcast. Please share this podcast, visit our website and follow our social media links.